guys. Jim Bounds, Motorhome Rehab Ranch. And for the guys that are following me on a daily basis, I know you're going, come on, I want to do the body pads and the gussets and stuff. I dig it. In the big picture of things, it'll be fine. But during this summer season, I really found a lot of folks had some problems with ground problems, corrosion, things like that. And also, when a lot of you guys call and say, "Well, what's this wire over here? What's going on here?" And what I found out I needed to do was to go back to some basics and handle those, and then get into what the problem is. Okay, so what I'd like to do on this video is to talk about a couple of basics. Now I know you guys that are advanced go, "Oh man, here we go. Let's not go watch this." Now, hold on. You may learn some things. You may see some things that maybe you always had questions of, because I want to try to answer a couple of those questions right now. Okay. Now it's kind of scary. You've got somebody that's left-handed and dyslexic trying to tell you how to left or right, right? Anyway, that's what I want to do here a little bit, right? Now, we're working with DC, direct current, okay? In having to do with this, there are two basic things you've heard in life: DC, direct current, and AC, right? Alternating current. Well, today we're not going to talk about anything about alternating current. No, sir. We're not going to talk about Tesla or all the cool stuff they did. We're gonna talk more about Edison and DC circuits a little bit. Now, your coach has two 12-volt electrical systems. It has a living area and it has an engine electrical system. Okay, and it has one AC system, whether it be from your generator or plugged in. We're not going to talk about any of the AC systems at all. We're going to talk DC, direct current. Your main static direct current source, of course, is your batteries. Boy, I'm getting deep, right? And your battery has a positive and a negative on it, right? And all of your engine electrical system batteries will be up front, okay? There's a boost solenoid. I was going to bring one, but that's okay. We're not going to even talk about it. But down as you pull up your passenger front hood, there's a boost solenoid. It's a silver cylinder, about 1.5 inches diameter, about 2 inches long, and it has a copper lug on each side of it. Okay, that is your boost solenoid. Okay, not to be confused with a Ford starter solenoid, which has a black plastic case and a silver top. It does have two things out the side, and it does have two terminals in the front, but it is not a solenoid. It is a Ford starter solenoid, but it also supplies the coil during start voltage and blah, 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 blah. That is not what we want in this application. We want a boost solenoid. So when you look at your boost solenoid, on the left side of the boost solenoid, all those wires going to that big terminal, is your living area electrical system. And the one on the right is your engine or your starting battery electrical system. And your starting battery will be connected with its positive to the right-hand side kind of looks like a cartoon character, but this battery, one way or the other, will be connected here. Now, this side is your living area. We're not going to talk about it right now. Okay? Well, we are, but not for purposes for a few minutes. So here's the deal. There's a theory called the Holes, H-O-L-E-S, theory of electron flow. Electrons flow supposedly the holes of where the electrons are supposed to be, right, flow from the negative terminal to the positive terminal because they're trying to get electrons. That flies in the face of everything that you and I think that we know about things, because power is supposed to flow from positive to negative. Well, honestly, in DC circuits, think of it that way. Think of your ground as negative, and think of your positive as your voltage. Hots and grounds. Okay? Now I'm going to completely confuse you, but just stay with me a little bit. Whenever you look inside your coach, your wiring, your wad, okay? If you have, and right now I'm going to talk about floor GM floor plan coaches, and then relate it what small differences there are to the Royales. But if you look in your dash, the black wires, okay, the black wires are going to be ground. Okay, black wires are going to be ground right here, except for the ones that aren't. What? There is a black positive wire going to the fuel selector switch. On the top of the fuel selector switch, it's black. Well, it's a hot wire. When you push the fuel selector switch, that black wire gets hot to energize the fuel solenoid. But in general, automotive and your GMC, because it was built in the automotive industry, black wires are ground. And in general, your primary wiring, what's primary wiring? Primary wiring is the big stuff, the stuff that holds current, like to your starter or from your alternator, things like that. Okay, your primary wiring will be red, unless somebody did their best and they didn't have any big heavy red wire and all they had was black and they put black in. Okay, but generally speaking, automotive application, primary power wire is red, and primary grounds are black. If you are a journeyman electrician, my brother-in-law was a journeyman electrician, and I had him working with me. We had all kinds of philosophical differences, because in the home electrical AC alternating current world, the black wires are hot, or your load, and all the white wires are ground, except for the ones that aren't. But generally speaking, in a house, if you've got a white wire, it's called a neutral wire. Okay, that's in AC. And generally speaking, the black wires are source wires. Okay, for 110. So right there, you can see a problem right there. In the AC world, black is hot. In the DC world, black is ground. Like, you'll buy some appliances, 12-volt lights from China, and they'll have the white as ground and the black as hot, because whoever is designing it is thinking used in home. Even though it's 12 volts, they still carry it over, and white and black are wired like houses. Okay? Generally, if you look at a drawing or something, greens are going to be ground, and what you're going to see is this little thing right here. That's a ground, and you, of course, you'll see a positive. Okay? Your coach is full of 50 years of good intentions. Okay? But if the guy was a journeyman electrician, it could have been wired like this. Okay? Not like he was an idiot. It's just that he was taught color codes differently. Now, I was taught DC circuits. Black is ground to me, and red is a hot to me. I was not trained in AC circuits. So until I got to the point of understanding this, I was wiring AC stuff like DC stuff. And it did work because it's just a passive circuit. But the wiring, the color codes were wrong. Okay. Now, on a Coachman, on a Royale, in the living area electrical system, which is usually under a sofa or behind something or in a cabinet, they really kind of hit them. You'll look in there and you'll see one terminal block with a bunch of white wires going to it. On Royale or Coachman or many of the transmodes, when you look at the living area 12-volt electrical system, all the grounds are white. What they did was they had separate grounds to every light, or every whatever in the 12-volt system. They had a ground and a hot. So you'll have, like, to a switch, a white wire, and then you'll have a blue and a green and a yellow. Well, that's 3 circuits, okay? But it uses the same ground. Make sense? Or those circuits come off of a white ground wire. All right? So the 12-volt electrical system in a Royale it's a discrete circuit. Discrete meaning it has a ground path. In a GM floor plan coach, all the grounds are common and they're to the chassis, like in a car, because the guys that design this are automotive guys. So generally speaking, they're going to be black wires, but the harness does not have a separate ground wire. They just ground it to everywhere. Make sense? Okay. The next video I'm going to do will be about meters and how to find that. But right now, what I wanted to talk about is hots and grounds as opposed to corrosion. Corrosion. Deterioration. Literally, something that's been made for 50 years has corrosion. It's rusted. The metal has reacted to oxygen, and it is caused to have a corrosion layer. And then damage over the years. I mean, one wire sitting in one spot for 50 years going like this against a piece of metal, it'll rub a hole in it. Good. So the 3 things that we're fighting with our motorhome 12-volt electrical system is corrosion, deterioration, and damage. Okay? Of all of these different colors and all this kind of stuff. The primary wiring in your coach, in other words, under the passenger front hood, the big wires, generally speaking, GM had them all red. And generally speaking, if you want to shut them down, the way most people think, remember we talked about the holes theory? The way most people think is that if you want to turn the battery off, take off the positive. Okay? Bubba, Scooter, their wives, they all think that way. And that's good. But you could just as easily, and for professional use, I built ambulances for a year and a half. And Bubba and Scooter would look at an ambulance wiring system and not know what to do at all, because all the switching is on the negative side. In the holes theory, all the current's at the negative. Well, you don't have a full circuit until you have positive and negative, right? So to be fancy or cool, or to say you knew what you were doing, you put the triggers and your shutoffs and everything on the negative side. Don't be surprised if you go in your coach and you see a battery switch on the negative or the ground. Okay? Not unusual. Only problem with that, to me, and I do understand it fully, is if you're in Lower Lompoc, and I know there's a place there, so I'm not down on anybody in Lower Lompoc, but if you're basically in the middle of nowhere and you get in there and somebody needs to help you or needing to remember something, our brains in America, Americans, our thought of power goes from positive to negative. Used to build car stereo stuff. And kids would bring their car and say, "This thing doesn't work. I don't understand it. I used all the big wiring." Well, they had a large power wire, but they had a little tiny ground wire. Well, it's not going to work because current flows in. You got to have a full current path, and the smallest wire is your maximum gauge, right? I have to recommend, because these motorhomes could go to places that you've not been before, and you don't know what assets you're going to have when you break down or you need some help. Maybe you, but you may need someone else's help. I really feel that we need to put the switches on the positive side and ground all the negatives. Okay? Because that's the way most Americans have done that. And if you get into the problem, well, what's the circuit? Is it a positive or a negative trigger? This and that. I really feel to keep things simple and keep it serviceable wherever you're going to be in the United States, at least, to put switches on the battery on the positive terminal. Coming off the battery, first thing you do is you go into a switch. Okay, the electrical design for a switch is like that. You want to put a switch in to shut the batteries off. No matter what happens, you want to shut off the batteries. So whatever battery you have first needs to go to a switch to shut it down. And whatever battery you have, because of convenience and understanding the circuit, it needs to be on the positive side. All right. I said all that to make sure we didn't have any of the guys that are electrical engineers to call them. Look, we can shut off the negative. Yeah, I like to do it. Look, if you like to do it, awesome, super duper. But when we had the place open, we were building things for people that didn't want to remember that or remember the Hole's theory of electron flow and all this kind of stuff. We just put it on the positive side. Now, all of those large wires. Let's forget. I don't want to forget all this. Actually, I'm not going to erase it right now. All of these wires have lived for 50 years or so in the real world. All the corrosion, if you're in Florida, if it stays here 6 weeks, it's going to have some mold on it. You know, you were in Arizona. You know, I've seen the cartoon. The guy, a skeleton in the chair, says, "Yeah, but it's dry heat." Heat deteriorates plastic. What does plastic do when it deteriorates? It shrinks. So if you have a holding tank and you look under your holding tank and you see cracks with a bunch of Guppy Pucky all over it, that roto-molded plastic tank or ABS or some other there, the plastic has reached its half-life and is starting to deteriorate on its own. And it's shrinking and it's cracking. So if you're looking for good money after bad, continue to try to fix that. If you want to do away with that and worry about something else, replace your holding tank. Here we are talking about holding tanks. We're on DC circuits. Okay, what I'm saying is that just from deterioration, your electrical system and corrosion will have problems. Guy called me yesterday. I don't know what happened. I went out there about 6 weeks ago, fired it up, let it sit and run and all this. I haven't moved it in a couple of years. Turned it off, come back out. Now I go to fire it and it just goes click, click, click. Won't start. Battery's good. It had a charger on the battery. All right. Let's talk about that situation. A couple of things. First of all, you've had the battery on a charger. How old's the battery? Because batteries to maintain a battery, you need to discharge it and then recharge it because it gets a memory. Okay? And if all you do is keep your battery charged all the time, when you take the cables off and it sits there, it will discharge quickly because it didn't know what it's supposed to do. You discharge it. If you go below 50%, okay, it will only come back to, 10% of its fullness. So don't decycle the battery, but don't keep it up all the time either. You need to cycle them. And batteries have life. You say, well, my battery is 6 years old, that thing's great. Run away quickly. Because when that battery fails, as voltage decreases, the amount of current it's going to take to do the same job is going to increase. Okay? So when your battery starts to not put out 13.1, by the way, it's not 12. 12.65 is a fully charged battery. 13.1 is a charged battery with a top charge. So when it won't go up to 13.1, it'll only go to 12.8 or 12.5 or whatever. This battery's starting to deteriorate. And as it does that, the current that's needed for that battery to do the same job increases, which puts more load on the devices. Lower voltage means higher current, which means more stress. Okay? So when that battery goes bad, it can take some of your other stuff with it, like the memory in your radio, things like that, low voltage. Okay, we'll talk about that again when we get on meters. But it is really, really important to cycle your battery. Okay, now, first thing you said, I kept the battery up all the time, and 6 months ago it fired right up. Now I hit it and it just clicks. All right. Could be the battery finally said, I'm tired of this hanging around doing nothing. It may have just said, I'm not doing it. It's very possible you need to check it. Put a voltmeter on it and turn the key. Try to start it. If the voltmeter does not drop and it won't start, that means that there's a circuit bad. If you hit the key and the voltmeter dives, voltage drops down, that battery is bad. Okay? So the first thing that I told him to do is to go take a voltmeter, put it on the battery, and hit the key. Does it dive or does it stay up? Okay? He said it stayed up. What that means is there's one of these circuits with all these wires on it is not transmitting enough voltage to kick the starter because he's got a good battery. Where'd it go? Where it went was in the junctions of all those big wires, those red wires, 12-volt primary wires. Okay? What happens is you've got a bolt with 3 wires going to it and the bolt's down tight. Okay? And it works just fine. Well, over years, the metal in those fittings have corrosion. And it builds up a film, very, very fine, light film. And it comes out of the metal. It's not like it's going to encroach into it because it's tight. But the metal itself exudes this corrosion. What happens? Enough of that corrosion gets between the terminals, and it doesn't pass anymore. It won't pass current. You may be able to read voltage through it, but it may not pass current. Why? Because the corrosion has built up inside there. Right? Now, age causes corrosion. We're 50 years old. There's corrosion everywhere on that base. Everywhere. Right? Simple way. If you have a problem, you turn the key, not going, things aren't working. Simple way to do it. Get a crescent wrench, small one, and go to every terminal where every one of those large wires is. Loosen the terminal a little bit and wiggle the wire back and forth, because doing this with the connector will scrape some of the corrosion away. Now, if you really want to do it good, take the bolt out, take each one, take some emery paper or sandpaper to it, and all this. If you do nothing more than loosen that bolt just a little and wiggle those wires big time all over and tighten it back down. Look at every one of the connectors going to the wires. Be sure they're like not really nasty or loose or anything like that. You may want to again, how far do you go? You may want to take the wire off and recrimp it, clean it up, every one of them, and put them back on. On every one of the, on the starter, on there's one big wire on the starter and there's one small wire. Clean them both. Look at the wires. Be sure that over the last 6 weeks, the corrosion got built up so bad that the wire won't pass. Say, well, how can wire? Wire is just a wire. But if wire has resistance from corrosion, has resistance. Resistance is heat. That's the problem we have with the nichrome wire. It is a 38-inch long wire that resists the flow of current, which resists voltage, to the light that runs the alternator light and runs the trigger circuit on our alternator. We don't want that nichrome wire, because why? It uses resistance. It heats up. And if it heats up enough and starts to melt the harness from the inside, that's our problem. Okay? We don't want that circuit. It's not that we want to put protection on the circuit. We don't want that circuit to be used at all. We don't want to use resistor wires. That's why, again, we're going to talk on other things. And there's some videos already out on one-wire alternators and all that. But let's not go there. What we're talking about is a bone stock GMC that's 50 years old. Every one of those two big connectors needs to be loosened, moved, and tightened back down good. And look at the wires. Be sure there's no damage. There's one wire on the front of a GM floor plan on 75 and after, 75, 6, 7, and 8. Remember we talked about this boost solenoid. On the left side of this boost solenoid is the living area electrical system. Well, coming off of here on a GM floor plan coach, you'll see a red wire come down and then go across the front crossmember. And it's held on with metal clips. It's a 2-gauge wire. It's a big, heavy gauge, big wire, red, goes across the front. It's not insulated, it's not protected. And with metal clips around that wire, if the insulation, the original red wire insulation, corrodes or has deteriorated or has rubbed and caused damage, that's a dead short. Okay, dead short. Funny thing, if you look at where that wire goes across the front crossmember and goes up, and just to the right of the wiper motor, it goes into the coach and goes all the way to the back. Well, that wire has split loom, or it has protection from there in the coach all the way to the other side. But on the outside, going down across the front and up to the boost solenoid, no protection, no insulation, none at all. And it goes right across the front of the motorhome. And for 50 years, all the dirt and junk's been going in there. Look down at that wire. You'll see it. If you see any cracks or anything, I know you will, if it's original. Here's what you need to do. You need to take that wire off of those wire clamps, those metal wire clamps. Put the clamp back down. Take a piece of 3/4 inch heater hose. Cut it right down the middle, all the way down. Okay, make a protection. Put that 2-gauge wire in that 3/4 inch heater hose, and then tie wrap that back to the original wire connector to hold it in place. But it needs to have protection on it. If the wire is already so corroded and nasty you want to replace it, right next to where the wiper motor is a flat spot on the footwell, the driver footwell. Right there on that flat spot, put a single terminal. Take the wire out of that comes out of the body, run it to the terminal, cut it off, put a nice connector on there, put it on that terminal, a single terminal, and then run a new wire down and across and insulate it across and come back up to the boost solenoid. Okay, this is everybody needs to do this or check it. because all the GM floor plan coaches from 75 on have this wire. Now, while we're talking about corrosion and damage and deterioration, that wire has got to be better protected than it was from the factory. Just at this age, it's got to be protected, or it needs to be replaced. Okay. We're talking here about hots and grounds and corrosion and deterioration and damage. I probably should have put this at the top, but everyone at this age, whether it's 50 years old and you got a 73, or it's 44 years old and you got a 78, whatever, you need to check all of the large wires, the primary power wires, for corrosion, and you need to treat them. Now, when you get finished, there's some stuff you can spray on, red stuff and all this, and that's good. I mean, if you're going to spend that much time and get them corroded, why not protect them? But, you know, here it is at 50 years, nobody ever put any protection on it. Now, you are at the point you got to check it, you got to fix it, but it did make it this long, so, you know, not bad. They've got that spray stuff that you can put on, and it really does work, and it is good to do. There's, on the next video I'm going to do is about the wire, the grounding, and all of the positive wires and stuff on each year. Okay, before I got to that, because in there I'm going to say this is a ground wire you need to check. The one ground wire that, as you go check everything, one you're going to have to seek out. There is a mesh braided ground strap on every coach from the factory. On the passenger side of the bell housing, between the motor and the transmission, on the bell housing, there'll be a ground strap from there over to the frame. Okay? In other words, it's grounding the motor for sure to the frame. You need to find it. Okay? You might be able to find it from the top, or certainly from the bottom. You need to find it. Number one, be sure it's still there. Number two, make sure that it's in good shape. And then number three, take the bolts loose, clean the connections up, and put it back in. Very important. I had a good friend who lives in Texas. Had the same problem. He had a gas station, stopped, put gas in it, wouldn't start. Thought it was a starter. The guy at the service station helped him put the starter in. He had an extra starter, put a starter in, wouldn't start. He called me. You know, I told him, go look for the ground wire. He said, well, the battery's good. He checked that. We changed the starter. We checked that. I said, go up next to the transmission on the passenger side and look for a ground strap and see if it looks good and all that. He called me back. He told the mechanic about that. He goes under there and says, there's not hooked up at all. It's just hanging there loose. And what happened, somewhere in the life of that motorhome, they had probably changed the transmission, took the bolt out, put the thing to the side, forgot to put it back on. And that thing, since that time, had been finding a ground somewhere else. Somewhere else, it was finding a ground, it was working, but it did not have the ground strap on it was supposed to have. So he put the ground strap on it, fired up, went on home. He said, you're a genius. No, it's just that I've seen this happen before. Now, I've seen those ground straps get so nasty that the pinch on each end on the connector lost connection. So nasty. So along with all these other wires up front that you're going to loosen and wiggle and put back, find your ground strap, find your motor's ground strap, and be sure it's connected. Also, from your engine battery, from your starting battery, right from the top of the battery, from the connector, there should be a 12-gauge ground wire, and it should go up to the aluminum plate in the passenger front hood. Yeah, I see you, Jeff. We're calling. I'll call you right back. So a lot of times people will replace that ground wire and say, well, what's this thing? We don't need that. Throw it away. to ground the body to the battery for all of the gauges and all the 12-volt stuff, it wants to have a ground right from the battery right to that aluminum plate. If you don't have that, you need to add that. Okay, while we're talking about primary wiring, that is a very, very important wire to be sure is there and it does its job. Okay. You go to a mechanic and say, well, this thing's got a problem. I don't understand. Well, he may not be able to figure it out either because he's not used to looking at a 50-year-old vehicle. He's trying to fix anything that walks in the door that's worth enough for somebody to bring it to a mechanic to get fixed. And chances are it's not going to be 50 years old. There are issues that a normal mechanic may not be accustomed to looking for. That make sense? Because that's not what they've been used to working with. This motorhome has unique problems, ghosts in the machine, because of connections, corroded wires, damaged wires, deteriorated wires. Okay, so if you want to do something to make you want to sit there and you admire your coach and it looks good and it's looking back at you, say, yeah, we're bad. Go get a wrench, get a couple screwdrivers and things, and go to every ground, every hot primary wire, and clean them all up. Look for your ground wire to your motor. There should also be, the generator should also have a ground. When it slides out, well, where does it get ground? Sometimes there's no ground on it, and it's getting its ground through the balls of the slide. It needs to have a good solid ground. So go back to your generator, pull it out, and see where the ground is. You look in there and say, man, it's a chocolate mess in there. Go get some Easy Off. Spray in there, clean it out. You know, look for your terminals, your power terminals. There's another one on your generator. On the side where the starter is power, 12 volts. It has a wire that goes through the metal cage and has a washer that insulates it from the metal cage. Comes under the top, it's got a bolt with a wire, and comes out the bottom of the bolt with a wire. It goes through the grounded metal cage with this unique insulator. Get down here and look at that thing. See what can get the condition that thing's in. Take the wires off, clean them all up. But if that insulator is looking kind of rough, you may want to think about changing that idea of running through that insulated thing through there and do it another way. Now it's got to move back and forth, but remember, it's got to have a good ground. It's got to have good power wire. So see what you can do to get it to do that, and maybe get rid of those through the cage things too. If you do all these things, the ghosts in the machine or things that happen and you don't even know about it may go away, right? A little bit of a long video today, but I've got preparation. The next video I'm going to do is how to read your voltmeter. People might have it. You know, that's what happened, fell down here. The infamous Harbor Freight red voltmeter. We're going to talk about this thing, talk about how to use it. Everybody should have one of these. I mean, they're like $5 or $6. They used to give them away, but I guess got a little bit pricier than that. But everybody should have one of these. If you don't have one of these, run out today and go get one. And we're going to talk about how to use this and how this came to be, why it's important to you. So watch that. We've got some other videos that'll be in our database along with this. Takeaway here is go clean all your connectors, all the wires, all the stuff, and get rid of corrosion. Look for damage and look for deterioration. Great. Well, I hope this helps a little bit. If it does, hit like and share and subscribe to the channel. you're doing it on YouTube. If you're on Patreon, thank you, Ranch Hands. Appreciate giving an opportunity to do all these things. And if you like this stuff, become a ranch hand. The Patreon page has prompts on it for ranch hands to make it much easier to search through the database. All right. So and this whole site is all about the database. I have a lot of you ranch hands follow me every day, and I appreciate that. And that's fun too. We did that for the Daily Post for 20 years. But along with that, now we're able to document this stuff and put it in a form that we can use it down the road. That's the important part. And that's what I appreciate you guys helping me do. All right. Look, we'll see you again. And if you have any questions, you got the number. Bye-bye.